Hello students, welcome back. We went through the exponential functions now. Now the next topic is logarithmic functions, but before that let's have a brief digression rather. Can I call it a review? I don't know. Let's have a brief digression about inverse functions. Some people know about inverse functions, some people don't. So let's have some digression. Let's begin with something called one-to-one function. So this kind of thing is called one-to-one function. This one is not one-to-one because two different x values are assigned to one y-coordinate value. This one is not even a function. One x-coordinate is assigned to two different y-coordinates. So this is a function but not one-to-one. This kind of thing is one-to-one. If you have one-to-one, you can come back. So one-to-one functions are often called an invertible function. One-to-one functions satisfy something called horizontal line test. Do you remember the vertical line test? Given x value is assigned to only one y-coordinate value in order to have a function, so it can be represented in a graph as a vertical line test. This one is a graph of a function. Given x value, we have only one y-coordinate. This one is not. We have two y-coordinate values from one x-coordinate. You cannot be in two different places at the same time. The program is randomized, so if you run again, you're going to get different vertical lines, but each time you have only one crossing here, but this one, not always. Now for one-to-one function, we do something similar, this time with horizontal line. We have horizontal line, and we have three crossings here in general. Here only one crossing, and this one also has multiple crossings, which means only the middle function, the right function, is a one-to-one function, and that is invertible. So if you have if you have a one-to-one function, it has inverse function defined backward. So xy is f, backward y to x, that's f inverse, and we use this notation, negative first power. That's not reciprocal, that is inverse expression. Once you have an inverse, then use your common sense. Domain becomes range and range becomes domain. Domain from range, that's one direction. If you go backward, then the other way around. Let's see, yeah, here's the picture. Domain becomes range, range becomes domain. And consequently, the graphs of inverse functions satisfy this kind of relation. You see, x goes to y, y goes to x. That's the inverse. Now here's the punchline. The graphs of inverse functions are symmetric with respect to the principal diagonal y equals to x, the blue function and red function in particular. Why is that? Well, let's look at this graph. X-axis green, y-axis brown, and if I fold this paper along this diagonal, the axis will precisely match, right? Do you see that from this? X-axis will go to y-axis, y-axis go to x-axis. That's precisely the same dynamic of inverse function. X goes to y, y goes to x. And that's why we have that kind of relation. Now, even if you forget about all those, the final relation you have to remember. By the way, this blue graph is the natural exponential function e to the x power, and the red function, red graph, is y equals to natural log of x, and that's the inverse function of this natural exponential function. And that's how we're going to define the logarithmic function. Just one more thing. Remember, what is the inverse function's basic role? X go to y, y go to x. So if you take inverse, x goes to y and y comes back to x, so you come back to the original place. Even if you start from y, again the same, y comes to x and then goes back to y. Let's see. It's a little bit harder to see with the graphs. So f sent x to y and then y to x, so we come back to x. If you start from y, so inverse y to x and x to y, so we come back to y. Here's another visualization. Start from here, x to y, and then y to x. That's what you have. Or if you start from y to x, and then x to y, so we come back to y. So, in short, we have cancellation rule. Yeah, x to y, y to x. Because of that, we have so-called the cancellation rule. Whenever inverse collides with the original, cancel each other out, we just get x. Cross each other out, we just get y. Make sense? Remember that because that's how we're going to define the logarithmic function and work out the computation of logarithmic functions. Okay, so much for inverse functions, and we're going to study logarithmic functions in the next video.